We're just gonna talk about something a little bit different, I thought this time. And so let me start off with what I'm doing here. Okay, so first we'll just talk a little bit about what's up in the night sky in the next few weeks because there's a full moon coming up. Some of the planets are up, some of them are not, but you could start looking for the constellation Orion. And there's also a meteor shower, which could be reasonable. Anyway, we'll talk about that. And then we're going to talk about Charles Messier and a catalog of astronomical objects that he compiled in 1781. So we need to think about, what was astronomy like in 1781 and how did he do this? And what are these objects? And it's kind of an interesting story. I had a lot of fun preparing this talk, and I learned a lot of things that I didn't know about the history of astronomy, and it made me think. So I hope it will be entertaining to you also.
What was
Okay,
it?
so first of all, the moon will be full on October 7th. This is called the hunter's moon by some people. It's also called the harvest moon by other people. Frankly, I think the idea of naming the moons like this is rather silly, but anyway, they do. And so here's just a nice little diagram that one can start looking for towards the end of the week and then on to next week. And in particular, if you look towards the east southeast 45 minutes after sunset on these days, you will see the moon and Saturn. So Saturn, isn't the brightest of the planets, but it turns out the moon will be quite close to Saturn on October 5th. And if any of you are ever interested, Sky and Telescope magazine puts out a summary of what's visible in the sky every Friday morning. And you can find it if you Google Sky and Telescope, Sky at a Glance. And I use those diagrams all the time, but I just thought I'd mention that. As far as the planets are concerned, this is not a great time to be observing planets. Mercury really isn't visible. Venus rises in the east an hour or so before dawn. So here's where it will be if you happen to be up early in the morning. But dawn happens later and later. So it's not so hard to actually see this if you get up at 6:30 in the morning. Mars is very low in the west northwest and is very hard to see. Jupiter rises around midnight, and so it's also visible in the early morning hours. And Saturn was at opposition, meaning opposite the sun from us on September 20th, and it rises in the east about an hour before sunset. And so if you wait a couple of hours after sunset, you'll see it in the east-southeast. The other thing that's of some interest is that there's a meteor shower called the Orionids, which peaks when the moon is new this month. And that's good because that means that there's not a lot of brightness in the sky from the moon. And it will peak on October 21st. And as the name might imply, it's close to the constellation of Orion. So here's a little picture of what the night sky might look like if you look out. In fact, it looks roughly like this if you're outside at 2 o'clock or 3 o'clock in the morning right now. But if you look out, you'll see that the meteors sort of should appear a little bit up from the red star Betelgeuse. And so you might take a look at that. And again, another convenient website to look at, you might have to study it a little bit, it's a little complicated, is if you go to timeanddate.com and if you Google Orionids observing, it will send you to a site which will give you a good handle on where to look in what direction of the sky at what time of night. You can set it up so that it's centered on what you should see from Ithaca, New York. So anyway, maybe it will be dark, maybe it will be clear, who knows, maybe it will be raining by then. Now that we're trying to look at something in the sky, the weather will undoubtedly get worse. We know that that's kind of the way it goes. Okay, so
Get the
what I'm going to
website
talk about is what we call Messier's catalog.
Martha,
or
can I interrupt for a minute? Can everybody please mute themselves? I'm
Yeah.
sorry to interrupt, Martha, but
Yeah. I didn't have that window open, so I didn't want to have to do that. I'm glad you did that, Betsy. Because sometimes we all forget. So here's a modern day picture of Messier's catalog, and we're going to look at some of these objects, but I just wanted to give an introduction to point out to you that this, of course, is modern. So we use colors when we take photographs, and you can see that some of the objects are red and some of them are kind of white and some of them are blue, and they have different structures. So we need to talk about the different kinds of objects, but the important thing is that Messier made this catalog. It has 110 objects in it, and they are still the kind of thing that you can observe with a small telescope, some of them even with binoculars, and a few of them have been known with since ancient times, which means they're actually visible to the naked eye if you're in a really dark place and have really good eyes. So anyway, let's talk a little bit about this catalog. So first of all, who was this guy? He lived from 1730 to 1817. Here's a picture of him at age 40. He became interested in astronomy at a very young age because he witnessed a comet. I'll talk a little bit more about that. And also an eclipse when he was a child. And so he found this really interesting. He came from a family in which his mother died young. His father actually died a little later. But in the meantime, his family got him lined him up so that he became an apprentice to a leader in the French Navy, where they actually did observing of the stars, and that actually became his job. His job was to observe the sky, and in particular, what he was doing was hunting for comets. And that will be important as we talk about what he noticed when he was looking for the comets was that there were objects that kind of looked like comets, but did not appear to move among the stars, and so they weren't comets. So I've tried to reproduce a couple of what he might have, a couple of images, one of a comet and one of his objects, in particular, the first object in his catalog. And I've tried to reproduce them as if he were observing them. He did have access to telescopes, but the telescopes he had access to were very small. So let's think about, what do telescopes do for us? They essentially do two things. They collect light. They essentially act like light buckets. If we think of light as being carried by particles that we call photons, then the bigger the bucket, the more light you carry or collect, and therefore the fainter the object you can see. So the bigger telescope, better. He had access only to small telescopes. It's believed that none of the telescopes he ever used was bigger than about 10 inches. They didn't have mirrors, they had lenses, and his favorite telescope was only 4 inches in diameter. So that's pretty small. What telescopes also do is they allow us to get a more detailed view of the structure of a celestial object. So here I just pulled out an image that shows you an image of a couple of galaxies taken with on the ground with a 4-meter telescope, and 4 meters, not inches. And here is the NASA Webb image of the same thing. And you can see that when you build a better telescope and you put it in space where you don't have any atmosphere, you get a better picture, a higher quality, better fidelity, better resolution. So telescopes are designed to give us better resolution. In general, a bigger telescope produces sharper images, but we have to keep in mind that telescopes like optical telescopes on the ground, like were used to make this image from the Dark Energy Survey instrument, Legacy Imaging Survey, they're affected by the Earth's atmosphere, which causes the images to be blurry, which is why you want to put telescopes in space. The other thing that we can do, which is what he did, was we can look to see if we look at the same patch of sky, if objects move. On human time scales, the stars remain fixed in position on the sky, one relative to the other. But solar system objects move among the stars. And so here's an actual animation of a series of images taken 6 seconds apart of a comet. And so again, what he had to be able to do was look at the sky and watch it over a period of time and see an object that looked a little fuzzy. He had to watch it move. Remember that the word planet actually comes from the Greek word for wanderer, because the planets, of course, as they move around the sun, they wander among the stars. But it's also important to notice, and this I didn't actually, I mean, I knew it, but I didn't do any work on it, didn't know the details, was he had no access to photography. So he had to remember all this in his head. And what he did, in fact, was he made sketches and he wrote down the positions of stars, and then he noted the positions of the comets and saw that they moved. And in terms of the objects in the Messier catalog, he noticed that these objects looked like comets, but they didn't move. As it turns out, astrophotography wasn't a thing until 1840. His catalog was published in 1781. And what I learned that was kind of interesting was it took them a while to figure out how to make astronomical images. And so I'm not really going to go through this, but basically the first images that was produced was actually a photograph of the moon made by John Draper in 1840. And it used a complicated process where a sheet of silver plate or copper was polished to a mirror finish. Then that sheet was treated with fumes that made it sensitive to light. Then the sheet was exposed in a camera for an appropriate length of time, depending on the brightness of the object. Then the sheet was fumed again with mercury vapor to make the image visible. Then they had some kind of a chemical treatment to sort of seal the image and not make it sensitive to the sheet, sensitive to light anymore. And then they rinsed it off, dried it, and put it behind glass. But it turns out that that was a really complicated process. It didn't work all the time. It required someone to be fastidious. And so, in fact, by the late 1850s, they had moved on to other techniques. But I thought it was kind of interesting to learn about that. But we have to keep in mind that Messier could only make sketches. He did not have access to all of the astronomical photography, which is so important to us today because we can expose longer and get deep images where you expose for hours on the Hubble Space Telescope to get the deepest images. He just could look through the telescope with his eye and take meticulous notes. I think it's much more challenging. Okay. So he was inspired because he saw a comet in 1744. and an annular solar eclipse in 1748. Remember, the annular solar eclipse is when the moon moves in front of the sun, but when it is further away from the Earth, the moon, so it doesn't completely block out the disk of the sun. We had one of those that occurred a few years ago before the total solar eclipse occurred. I'll talk about the comet in a minute because the comet he was lucky enough to observe was very unusual, but luck has played a role in his life by inspiring his interest at a young age in astronomy. So in 1751, when he was 21 years old, after being apprenticed to somebody in the French Navy, he actually started working for the astronomer of the French Navy. Navies had a tendency to have astronomers on staff because they used celestial navigation to figure out where the ships were and to figure out how to keep time. And his boss instructed him to keep very careful records, and so that's what he did. And his first documented observation was of a transit of the planet Mercury in front of the disk of the sun, exactly lined up. It's hard to see here, but there are a bunch of little dots. Here's another example of a single exposure with a small telescope of the planet Mercury moving in front of the sun. So it's like an eclipse, but of course, the planet is much smaller than the sun because the planet is much further away from the Earth. So that occurred, his first observation. It took him 2 years of work to make his first documented observation. The other phenomenon that I mentioned was he was inspired to study the skies because he observed a comet when he was 14 years old in 1744. But this wasn't just any comet. It's called the Great Comet of 1744. And here's an illustration of it. And what's really weird about this comet is it had 6 tails and was visible to the naked eye during the daytime. That is a very unusual comet. It passed by the sun, closer to the sun than the Earth by a factor of 5. Its orbit is uncertain, but based on the recordings of observations, it's possible that it is a periodic comet that comes by every 300 or 400 years and had been previously reported. In fact, it's believed that it might have been Caesar's comet, which occurred in 44 BC CE, and another comet of 676. Why do comets have tails? Comets we like to call dirty snowballs. They're made of frozen gas and dust, and they travel in highly elongated orbits around the sun. And as they come in, the radiation from the sun actually exerts pressure and, of course, has heat. And it causes the outer layers of the comet to be pulled back, forming a tail. And typically the tail will always point away from the direction of the comet straight to the sun. And so as we watch comets, they will have tails, and the orientation of the tail will depend as the comet gets closer and then moves further away from the sun. We think that multiple tails can form if you just don't have a single dirty snowball. You might have a bunch of dirty snowballs that are kind of compacted together. It's not a nice little ball. It has lumps in it. So that would explain the number of tails. I just thought it might also be interesting to think about. Here's a picture of a comet, again, taken this one with a small telescope. You can see in the night sky the comet, and very faintly you can see the tail. Here's a close-up of a comet taken with a satellite that was sent to the comet by the Rosetta spacecraft that was sent to take a picture of a comet. And you can see a comet isn't a nice little snowball. They're complicated structures. They're of stuff stuck together, rock, ice, dust around, and that the fact that there's this funny looking snowball that's rotating around, that's what can lead to the formation of multiple tails. The nucleus of a comet, such as depicted here, is typically only 10 miles across, but the tails can be hundreds of millions of miles long. The amount of material in any little part of the tail is minuscule. Anyway, so here's what's believed to be the orbit of the comet, a very elongated orbit. If it is periodic, which again is not certain, it has a period of coming back into the inner part of the solar system of 300 or 400 years. And so it comes back in. Here's Mercury, Venus, Earth, and Mars. And so that's its orbit. So we think that this is one of the things that inspired him to become a comet hunter. Just another historical note, because it's going on at the same time as these other things again, so he would have known about this presumably. Edmund Halley was also interested in comets. He compiled a list of 24 comet observations by different historical observers. He understood that Jupiter and Saturn could impact a comet's orbit, and so he was able, from the observations and his understanding of physics and the gravity and mechanics, which was pretty crude at that time, he came up with the idea that several comets that had appeared were reported in 1531, 1607, and 1682 were actually different appearances of the same comet. He predicted that that same comet would be back in 1758, and of course that's what we call Halley's Comet. So Messier spent his entire working career hunting for comets. He's credited with discovering 13 on his own, and he's the co-discoverer of several others. And King Louis XV gave him the nickname the Ferret of Comets. So that is our story of Charles Messier, the comet hunter. However, remember that he's looking at the sky and he sees objects. He's just looking with his small telescope around the sky. And once in a while, he comes across an object that kind of looks fuzzy, like a comet. But it turns out those objects don't move among the sky. And being the meticulous observer that he is, and the fact that he doesn't have the ability to take images, and he's been taught to take careful notes, he makes a list of these fake comets or his rejected comets. He makes a list, and that is the diffuse objects which are fixed with respect to the stars, but which he doesn't want to run across them again and not remember, oh, that object, it's not a comet. I don't care about that. I'm going to move on and go look elsewhere for comets. So his catalog is actually a list of his rejected comets. So I just thought we'd take a look at some of them. Again, he scanned the sky looking for comets. Here is what you might see if you look with binoculars or a small refracting telescope. Here's a comet. Here's Messier 1, the first object in his catalog. And here's Messier 31, the 31st object in his catalog. The catalog was compiled and published in several stages. The first contained 45 objects. The final version contained 103 objects, but a few of those actually had side notes so that the final number today is 110. He actually discovered for the first time and recorded their presence only 18 of them. Most of them, in looking at records, he realized someone else had reported, but did not say, this is a rejected comet, and put it in his list. So anyway, let's take a look at the catalog. There's a nice website, astropixels.com, that has links to, it has a summary of all the different objects, tells you when they're visible with a small telescope, gives you their coordinates, right ascension and declination on the sky, the constellation they're in, and a little bit of information about what kind of objects they are and how far away. And it has links to images. So if you're interested, you can find his catalog there. If we actually look at his catalog, it looks like this, and it's reported in the third person. It says that he has observed with the utmost care the nebulae and star clusters which one can detect above the horizon of Paris. He's determined their right ascension and declination and given their diameters, together with circumstantial details for each one, a work which was missing in astronomy. He also gives details to the searches he has made for those other nebulae which other astronomers have discovered, but which he looked for without success. So he also has a few other objects which someone else said was there and he couldn't find. Again, here's what the catalog looks like. There's the left-hand side gives the different objects, and it's recorded the date of his observations, the position in the sky, and then there's a description of each object. So here's another view, again, like the earlier one that I showed you, but this is a compilation made up with relatively small telescopes, but using astrophotography. A big difference is that it's much harder to discern color. The naked eye has much more trouble discerning color than we do when you look with a camera and take a picture. So this shows the obvious different colors, and we're going to take a look at a few of these different objects. So here's the first object, Messier 1. Here is the picture of the object. It's in the constellation of Taurus, and he noticed that it looks like a nebula. So what is a nebula? A nebula is a diffuse object, fuzzy object. He also records some clusters of stars. And so we'll take a look at those. Stars, of course, look like points of light. If we look at the 110 objects, and here are some modern pictures because the other pictures don't look so good, we see clusters of stars and we see nebulae. Among the 110 objects, there are 27 what we call open clusters, which are loose collections of stars like this one. Typically, they contain hundreds to thousands of stars. You might only see tens if you look with them with a small telescope, but if you look with a Hubble Space Telescope, you'll see hundreds to thousands. All of the stars as we understand them in these open clusters, the stars formed at the same time, and they're relatively young. Another category of the star clusters are what we call globular clusters. These are typically much tighter and much bigger collections of stars, tens of thousands to hundreds of thousands of stars formed at the same time out of the same cloud, but they have a tendency to be relatively old. Then there are what we call the diffuse nebulae. They are clouds of interstellar gas and dust in the Milky Way. And there's another category of those that are similar, but which are called planetary nebulae. And as we'll talk about, and I've talked about before, it's a complete misnomer. Planetary nebulae have nothing to do with planets, other than to the first observers looking at them with small telescopes who didn't know what they were. They looked fuzzy and green like the planet Uranus. And so it was realized they probably weren't planets. They were nebulae, but they looked like Uranus, so we're going to call them planetary nebulae. Complete misnomer. But we have to give the people credit. They didn't know what they were looking at. They didn't have much assistance, but they discovered these things. Okay, and then we're also going to find out that 40 of the objects are nebulae, but they're actually galaxies. Here is one of them. This galaxy, and we'll talk about a few of them. Galaxies are nebulae in that they're not stellar point-like objects, not made up just of stars, but they, of course, contain billions and billions of stars and are much further away. Okay, let's take a look at a few more. So here's Messier number 1, the Crab Nebula, the one in the constellation of Taurus. It's actually the remnant of the explosion of a massive star that has undergone a supernova. It corresponds to a guest star, which suddenly appeared and was recorded by both Chinese and Arabic astronomers in the summer of 1054 current era. It's located in Taurus, and the supernova was brighter than Venus and visible in the daytime for several weeks. The star that actually exploded is located at the center of the nebula. The nebula itself is the outer part of the star, which has been exploding outward since 1054 AD. Here's a more modern image taken with a relatively small telescope of it. And this is a sequence of several images taken of two images that were taken 30 years apart with the same telescope. And you can see the gas expanding. Okay, let's think a little bit more about this. This is a very interesting object. So what we're actually seeing in this is a debris cloud of gas and dust that has been blown off the star when the star had a catastrophic collapse in its center and then exploded its outer layers. The star, the remnant of the star, is right there where my cursor is. I hope you can see the cursor. The star turns out to now be more massive than the sun, but is the size of Manhattan. It's what we call a neutron star. In this picture, you're seeing in the red the image from the Hubble Space Telescope, and in their blue, you're seeing images from the Chandra X-ray Observatory, which is telling us that the gas in the blue is very, very hot. So the crab is the result of a supernova in 1054. The nebula wouldn't have been visible immediately, and in fact, it was first identified by John Bevis in 1731. It was rediscovered by Messier, who included it as number 1 in his catalog. In 1921, Lampland reported seeing changes in the nebula's structure, like what we saw in the two images that were flipping back and forth a minute ago. In 1968, Stalin and Riefenstein discovered a radio pulsar at its center. What that is located in, this is an X-ray image, but right at the center, there's an object which is a rapidly rotating star made up of nuclear material, neutrons. It's rapidly rotating 33 times every second. Again, it has the mass greater than the mass of the sun, the size of Manhattan, and it's rotating 33 times a second. So here's our picture of what's happening. You can see this is over a number of year period where you're seeing a time lapse of the crab expanding and motion of the jets resulting from the pulsar. Here's a little picture of what we think is happening in the pulsar. This rapidly rotating neutron star has what you might consider like lighthouse beams. We see a pulse of radiation, both in the X-rays, in the optical, and at radio, 33 times a second when the beam points towards us. So this is kind of an interesting object. Okay, let's go on to a different object. That was Messier number 1. Here's Messier 45. This is also known as the Pleiades star cluster. Here's what it looks like if you look at it with a small telescope. It's an open cluster. Wait a minute. It's an open cluster in the constellation of Taurus. It's relatively young. It contains hundreds of stars within a diameter of about 20 light years. Let's remember that the distance to the nearest star from the sun is about 4 light years. So if you just go out 5 times that or so, in this case, you'd find hundreds of massive stars. It's a very different place than the environment than the sun is. It's easily identifiable in the night sky in Ithaca. It was known in antiquity, at least going back to 1600 BCE. It was called the Seven Sisters. It was one of the objects that Galileo looked at, saw many more stars than you could see with the naked eye, and said, the heavens is full of all sorts of stuff that we don't know about. And that leads me to believe that there is more to the universe than the Earth and the sun. It was noted by Messier in 1769. This is the evidence of the fact that the ancients knew about the Pleiades. This is called the Nebra disk, which was discovered in 1999 in a hill near Nebra, Germany, and it's believed that these 7 stars represent the Pleiades. It's believed to date back to about 1600 BCE. So if you go out tonight around midnight and you look up in the east, you ought to be able to identify the constellation of Orion. Remember, here's Betelgeuse, the red star, Rigel, the blue star, and here's Orion, and here's the Hunter. And if you go follow the Hunter's belt up, you come to the red star Aldebaran in the constellation of Taurus. And if you keep going up, you'll see what looks like a little dipper. I was out at 3 o'clock in the morning a few nights ago, and it was almost overhead. It's really easy to find. It's the only thing that looks like a little dipper. And in fact, it's much easier to see than the Little Dipper is. Here's another picture. Again, this is what it will look like. A little dipper, but on a much smaller scale than the constellation we call the Little Dipper. So here's a view through the small telescope. Here's the view through the modern telescope. What you're seeing in the modern telescope is you get to see gas and dust, which is left over from the formation of these stars because these stars are very young. They were formed about 100 million years ago. The sun was formed 4.5 billion years ago. So these are really young stars. The stars heat up the gas and dust in the remnant of the cloud that they formed out of. We think all the stars formed at the same time out of the same cloud. The stars form and then they heat up the gas, and so you end up with this nebulosity around the stars, and that helps to make the thing look different. Okay, let's talk about another star cluster. This is Messier 35. It's another open cluster. Again, we're going to talk about globular clusters, which contain hundreds of thousands of stars, and open clusters, which contain more like 1,000 to 10,000 stars. Open clusters are young, much, much younger than the sun. Globular clusters have a tendency to be even older than the sun. So this one was discovered in 1745 and independently by John Bevis. Its age is about 100 million years. Here's what you would see in a small telescope, such as what our friend Charles Messier might have seen. Here is what you see when you look at it with the Hubble Space Telescope. For reasons that I'm not really sure I understand, this is called the shoe buckle star cluster. It's like naming moons. I don't get it all the time, but anyway. Okay, so those are open clusters. Here's what you would see if you looked with a small telescope at what is Messier object number 13, the Great Hercules Cluster, a globular cluster located in the constellation of Hercules, which is visible principally in the summertime. And again, this is what you see, a fuzzy, blobby thing, but it looks like it's a collection of points of light. It's a star cluster versus a nebula, which is more diffuse and gaseous. It's a gravitationally bound collection of objects which are in orbit around a common center. Here's the small telescope. Here's the slightly bigger telescope. Here's the optical image with the Hubble Space Telescope. It contains hundreds of thousands of stars and is billions of years old. And here's another one I just throw out because it's a little bit different from M13. This cluster also contains 100,000 stars, which all formed out of the same cloud of gas and dust about 25 billion years ago, 12.5 billion years ago, so quite a bit older than the sun. But what's interesting about this one is that in the center of it, there's what we call an intermediate mass black hole, about 4,000 times the mass of the sun. That's a relatively new discovery. The cluster itself, visible through a small telescope, discovered in 1746 by another comet hunter who presumably needed this Messier catalog, but it hadn't been published first. It's only been in the last 10 years or so that it's been realized that at the center, there's this intermediate mass black hole of 4,000 times the mass of the sun. Okay, on to another one, Messier 57, visible in the summertime with small telescopes. It's called the Ring Nebula. Here's what it would have looked like to Messier in his little telescope. Here's what it looks like with JWST. Obviously, we learn a lot more, and what we know about a planetary nebula, it doesn't have anything to do with planets other than that it kind of looks like Uranus through a small telescope. A planetary nebula is formed when a star near the end of its life expels its outer layers not in a supernova, but in a less catastrophic manner. And the sun will actually go through this phase in about 5 billion years from now, in the future, not to worry about it. Messier actually discovered this object in 1779. We are able, with JWST, Hubble before it, and ground-based telescopes, we can actually watch the expansion of the outer layers. And it's suggested that this object also has been expanding for about 1,000 years, but it wasn't a supernova, so nobody noticed it 1,000 years ago when it underwent its explosion. Okay, another one. Now we'll go on to the nebulae. This is the Orion Nebula, Messier 42. Here is Messier's actual drawing of this object. And here's a picture of the night sky with the constellation of Orion, the hunter, Betelgeuse, Rigel, the hunter's belt, and the hunter's sword. And if you look carefully or take a picture, one can see that these stars are blue. This one is red. And in the sword, there's a fuzzy red object, which is the Orion Nebula. Here's what it looks like through a small telescope, again. And here's what it looks like if you use the Hubble Space Telescope. Here's the picture from Messier. Here's the picture from Hubble. We are very lucky, but he did the best that he could. But again, no photography, no color, just your eye. This nebula is a diffuse object, a cloud of gas and dust. It has stars embedded in it. It also has stars in the foreground, so they're easy to see. Its entire mass is about 2,000 times that of the sun. And it's a stellar nursery. Stars are forming there today, right now, as we watch. Okay, let's move on to the galaxies. So those objects that we've been looking at are all objects that are part of our Milky Way galaxy. Now we have to look outside of the Milky Way at objects which are much further away and which are galaxies like the Milky Way and contain billions and billions of stars, but they're so far away that they look kind of fuzzy. So this is the Andromeda Nebula, Messier 31, or the Andromeda Galaxy. It's the nearest large galaxy to us. And this is what it looks like through a small telescope. It can be found in the fall sky, in particular the constellation of Cassiopeia, which looks like a W, is up there in the northeast of the sky, close to overhead these days. And if you look at a couple of other bright stars, Alpheratz and Merak, and in between them, you can locate, with a pair of binoculars, you can locate the Andromeda Galaxy. It's quite visible in a pair of binoculars. But one of the things that I think is interesting is this is AI generated. It's not a real photo. But what it attempts to show is the scale of Andromeda on the sky. It's actually 6 times the size of the full moon. But because it's so far away, it appears very, very faint, like this, instead of a full moon in your telescope. But it is really big, and it's diffuse. It is a galaxy. It's composed of billions and billions of stars, gas clouds, dust clouds, dark matter. The first written observation of it was made in 964 by a Persian astronomer. It is possible to see it with the naked eye if you have really discerning eyes and you're in a really dark place. So perhaps he saw it without the use of any lenses. It's at a distance of 2.5 million light years away from us, and it's somewhat more massive and larger than the Milky Way. And this is what it looks like. You can see the dust which causes the starlight behind it to be blocked out. The stars are so closely packed together that it looks like a solid object, but you're just seeing billions and billions of stars. Okay, this is the last one we're going to look at. It's the most distant Messier object. It's located 62 million light years away. So Andromeda is at 2.5 million. Most distant is at 62 million light years away. It was discovered by Messier in 1779. Again, we see different images. Here's an image through probably a 10-inch telescope where you actually see some of the structure. Here's an optical image taken with color. You see the stars. You also see hot gas. These are the massive stars that form the spiral arms. And in the right image, which comes from the Spitzer Space Telescope, you're seeing the old stars and the dust. And so you can compare the two and see that there's some similarities and some differences between what you see in the different telescopes. So I hope I've given you a little bit of a feeling of the different kinds of objects that Messier found. I hope you've reflected on the fact that this man went out every clear night, and he lived in Paris. And the weather in Paris isn't all that much better than the weather in Ithaca. So think about that. He must have spent plenty of nights at home or at the bar because it was too cloudy to observe anything. But he just doggedly went out and he made observations. He didn't have photography. He had to keep notes. And he was hunting for comets. He only discovered 13 in his lifetime. But he also noticed this other set of objects, and he didn't want to stumble across them again and then spend time thinking they were comets. And so his real legacy, he's not known for his discovery of comets. He's known for the fact that he took this meticulous scanning of the sky and made note of what he was not looking for, his rejects. And that has become his legacy. So anyway, that's the story of Charles Messier. I thought it was kind of fun, and I hope you did too. So does anybody have any questions?
I do.
Yeah, sure.
He lived in a big city, Paris, and today, if he were out there trying to observe, presumably the city lights would make it almost impossible for him to see anything. But I take it that in his day, there wasn't enough light emitted from the city to make it a disadvantage to be there.
There are lots of observatories that are located in cities.
Uh-huh.
The Paris Observatory is in Paris. It's located, it's not in downtown. It's a few kilometers away, a few miles away from the Seine, and it's kind of on a hill. But yeah, the night light pollution wasn't what it is today. The weather was the same. But to me, one of the things that was interesting about this was thinking about the fact that he didn't have astrophotography. Everything was based on his ability to find patterns of stars and he knew about coordinate systems, which is the Navy wanted to know about how you could use celestial navigation to figure out where your ship was and how to get it to wherever you wanted to go. And so he knew about that, certainly, but he made meticulous notes. And I hope I've conveyed the impression that this required a lot of very careful work. But it's kind of ironic that what he's known for is actually the stuff he was not interested in. So anyway, that's my little story for today. And I hope you thought it was interesting.
Martha, I have a question for you.
Sure.
these galaxies and stars are so far away. You showed one image in which I think there was a comparison that was done 30 years apart to show that there was some movement. How long is it today that it takes for astronomers to tell that there has been a change in a galaxy that's hundreds of millions of light years away? When, it seems to me in a lifespan, you wouldn't see any change.
For most objects, you don't see any change. And it's really so most of the objects, the object that I showed you that you saw the expansion of, and the other one I referred to, the Ring Nebula, also it's been observed to be expanding. Those are in the Milky Way galaxy. They're only thousands of light years away. And so if you can make very, very precise images, like with the Hubble Space Telescope or other large telescopes, and you compare ones taken over 20 or 30 years, you can see that the nebula has expanded by a little bit. If you look at it, it didn't, expand hugely, but we can actually watch planetary nebulae and supernovae. We can watch the debris remnants, as we call them. We can watch those move over periods of decades. And
Okay.
now in 2025, we've had some of these telescopes, like the Palomar 5-meter telescope and other big telescopes, we've had them for 70, 75 years. And there are even astronomical photographic plates that go back to the 1850s, 1860s, 1870s. So people can look and see things. In terms of galaxies, they are much further away. And so to actually see them move requires longer periods of time. But we are able to make some really high precision observations of stars in those galaxies, or what we call masers in those galaxies. And over periods of 5-10 years, we have managed to detect the motions of those galaxies to actually watch them. And this is one of the kinds of things that the Rubin Observatory will specialize in, is looking. Rubin is designed to do what is called the Legacy Survey of Space and Time, which is going to take images. It's going to image the part of the sky that is visible to the telescope, which is located in Chile. It's going to repeat observations of the whole sky every 3 nights. And then it has some parts of the sky which it will observe every hour, other parts of the sky it will observe every day, and other things that will be done on different time scales, and to different levels of faintness. And it's going to look for objects that move and objects that change in brightness. And so it's going to detect, well, when they had an announcement and they released some of the first images from Rubin, they had already discovered, I think it was 3,000 asteroids that we didn't know were there before. So, but again, it's much easier to do when you can take digital photographs and then use computers to compare them. It's another thing to be Charles Messier and you're making your little sketches. Alan? You had a
Thank you.
question?
Yes, you mentioned this relatively recent intermediate-sized black hole discovery. Is it believed that most globular clusters would have one of those?
That's a really interesting question. We don't understand intermediate mass black holes in the context of how we understand black holes exist. because black holes result from the implosion of a single star, and there are no stars that have masses of 10,000 solar masses. So we don't really quite understand how it exists, except it must exist. They must exist because of the coalescence of multiple of these black holes. It's also like the very early supermassive black holes in the very distant universe. Our current theories don't really allow us to produce them on very short time scales because somehow you've managed to take a lot of matter and merge it together, but not blow it apart. And the intermediate mass black hole has to somehow exist. And the fact that this is in a globular cluster is what people predicted. They predicted that maybe at the center of every globular cluster, you have an intermediate mass black hole. But there's only evidence for a few of them. This is one of the better cases. So it's another one of those things that puzzles us even today. But of course, that's what makes them interesting. And I picked that one because I think it's interesting to try and understand where that black hole comes from. Because it's not just the simple story that we tell about how black holes form. You have a massive star of 10 or 20 solar masses, and at the end of its life, it blows up in a supernova. And if the core can't hold itself up against nuclear forces, it continues to collapse and you get a black hole. Nice story, but you can't make a 10,000 solar mass or a 4,000 solar mass black hole that way. So we don't really understand where they come from, but one could imagine that if they could exist anywhere, at the center of a globular cluster would be a good place to look. But why don't we see them in all globular clusters then?
I also have a slightly silly question. You may not want to answer it. There is this idea of a Messier marathon, the idea of observing the entire
Right.
Messier
A
catalog
lot of
in one
people do
night.
that. A lot of people do that. It's hard to do in one night because not all of the objects would be above the horizon.
Well, there are some nights, I think, when they are actually.
Well, maybe close.
But you sort of answered most of what I was about to ask. You said a lot of people do it. I was going to ask you how many people roughly you might know who have done it.
I don't know anyone who's done it, although I suspect I know people who've done it. They've just never admitted it.
Sure.
You'd want to be in a dark place and have a reasonable size telescope. But yeah, you could do it because they're not all that faint. And we know where they are, which our friend Charles did not until he made the catalog. But it is one of the things that people do, amateur astronomers do for fun. Let's go observe all the Messier objects.
Thanks.
But you all can go find the Pleiades. And this is starting to be the time of the year when it should be easy to do. You don't have to get up at 3 o'clock in the morning if we wait a month or so. So we'll revisit it and see if everybody can find it. Okay, well, I hope that was interesting. And
Thank you.
there was a little bit off the wall. I'll think of some other topics. I've promised David Brown to give a talk on dark energy, but I haven't gotten up the energy to prepare that talk. And I'm going to talk sometime about neutron stars and black holes as a result of stellar evolution at some point. And whatever else happens in the next few months, there are always new things happening in the sky.
So Martha, am I right? I should know, but last series you did, we alternated between 4 and 7, but this particular series is all going to be at 4. Is that correct?
I don't remember, Betsy.
I don't remember either, and I should know. Okay, just make sure that you look at the time.
Right. Anyway. Okay.
Thank you so
Thanks,
much,
everybody.
Martha.
Thank you again.
Thank
Bye-bye.
you.
Bye.
Bye-bye.